A request has come in for me to do question 7 out of exercise 3B. We haven't actually covered this work yet, but I'm going to do it anyway because it does lead us into what we are covering on Monday's lesson, where we're looking at proof by mathematical induction for when we're looking at multiples or when a number is divisible by a particular number. So, as you can see here, we've got the question 7a and question 7b. Now, in a question when it's written like this, and this is a good hint for exams, is question A is there for a reason. And so therefore we're going to use our solution in question A to assist us to solve the one for question B. So when it says question A, expand 2k minus 1 to the power of 5 and 2k plus 1 to the power of 5, they are there to guide us into what we should do to solve B. So expanding 2k minus 1 to the power of 5, I'm going to do these up here. So 2k minus 1 to the power of 5. Okay, now we're going to use binomial expansion. And so binomial expansion involves the first term raised to the power of 5 and the second term raised to the power of 0. So it's a negative 1. So I'm going to do it. There will be coefficients and we'll deal with those in a minute. So 2k to the power of 4 times negative 1 to the power of 1. Scroll across, plus 2k cubed negative 1 squared plus 2k squared negative 1 cubed plus, and you notice I'm leaving a gap deliberately because I haven't done the coefficients yet, 2k to the power of 1 negative 1 to the power of 4 plus 2k to the power of 0. I'll put it in like the 2 would normally every time, and then negative 1 to the power of 5. Now, coefficients for the fifth row of Pascal's triangle are 1, 5, 10, 10, 5, 1. Now, if you remember from our work with combinations, that was 5C5, 5C4, 5C3, 5C2, 5C1, and 5C0 to get those coefficients. All right, so to save some time, I'm just going to assume that you can expand that yourself. Basically, we're going to get 32k to the power of 5 minus 80k to the power of 4 plus 80k cubed minus 40k squared plus 10k minus 1. Okay, and again, you can test that for yourself. And just to finish off this bit quickly, because it's not really what we're trying to do here, although we do need it for our next question. 32k to the 5 plus 80k to the 4 plus 80k3 plus 40k squared plus 10k plus 1. Okay, so we're going to need both of those solutions to help us answer question number 2, or B, sorry. So, prove by induction that n squared minus 5 is divisible by 240 for each odd positive integer. So there's the key word there, odd positive integer. So the first thing we do when we're proving by induction is we identify our postulate or our proposition. So we're going to say that P to n equals n to the power of 5 minus 5, minus n, apologies, minus n is divisible by 240. Okay, so the first step when we're doing mathematical induction is we'll do it for the first value. So the first odd positive integer is 1. Okay, so we're going to prove it for n equals 1. So therefore, pardon me, n to the power of 5, so it's going to be 1 to the power of 5 minus 1 equals 0. Now, is that true? Well, I guess so. Is true. Okay, so we're told there that 0 is divisible by 240, so therefore it must be true. Second part of the induction proof is that we're going to say it's true for a value of k. Okay, so we're going to let k, all right, be a natural, or so k is going to be a value. Okay, it's going to be a natural number, but it needs to be odd. So we need to define it to be odd. So I'm going to define it with 2n minus 1, or 2m. Okay, not n. So we're just going to define it with a value of m, where m is any counting number. Okay, so that's an odd number, 2n minus 1. Okay, and we're going to assume p to the k is true. Okay, so what would that look like? Well, it's going to be 2m minus 1 to the power of 5 minus 2m minus 1. Okay, and we're going to assume that this is true, is divisible by 240. So we're assuming that's true, so we better work out what this is. So 2m minus 1 to the power of 5 minus 2m minus 1 is equal to, well, 2m minus 1 to the power of 5 was did up here. So that's going to be, whoopsie, I can see it, 32k to the 5 minus 80k to the 4 plus 80k cubed minus 40k squared plus 10k minus 1, whoops, minus 1 minus, yeah, I shouldn't have m's, k's, should I? So what I'm going to do is replace all of those k's with m's because I'm doing 2m minus 1. So that's going to be an m, an m, an m, an m, an m minus 2m minus 1. Okay? So therefore, let's just simplify that a little bit. So therefore we can say that this, so that's 32m5 minus 80m4 plus 80m3 minus 40m squared, 10m minus 2m is 8m, negative 1 plus 1 is 0. That's going to be, and what we know that's equal to, and so we're going to say that's equal to, I'll put it in blue so it stands out, 240p. Okay, where p is a natural number because we want it to be an odd number. So we can call it any value we want. Okay, in previous examples, or in other examples, you might see m as the multiplier, but we've already used m for this question, so therefore we're going to use p. It doesn't really make any difference. But the 240p is what defines the answer to that whole equation to be a multiple of 240. Okay, so that's the step. So then we're going to assume that that is true. So the third and final step, oops, need to be in red, it didn't work. Let's try that again. Okay, is that we need to prove that the next, okay, so we need to prove the next odd number is true. So if 2m minus 1 is the odd number that we've assumed is true, the next odd number is 2m plus 1. And hopefully you can now see why we did the previous question. So we're going to try that. So therefore, 2m plus 1 to the power of 5 minus 2m plus 1. Okay, we're going to see what that looks like. So we'll expand that out. So again, we're going to use that up there. So it's the same except they're all pluses. So we've got 32m to the 5 plus 80m to the 4 plus 80m cubed plus 40m squared plus 10m plus 1 minus 2m plus 1. Okay, so we're going to tidy that up. So that's going to be 32m to the 5 plus 80m to the 4 plus 80m cubed plus 40m squared plus 10, plus 8m. 10m minus 2m is 8m 1 minus 1 is 0, so it drops off again. Okay, so we've tied that up. So I'm going to come back up here. We're going to call this equation up here equation number 1. I'm going to call this equation number 2. Okay, so what we can do is we go from equation number 1. So from equation number 1, we're going to try and work out a way that we can equate these things. So as you can see, in the first one we've got some things that are the same. Right, they're the same, and some things that are different. So why don't we try and equate things that are the same in equation 1? So we'll do that. So what we're going to do is say, 32m to the 5 plus 80m to the 4, no, sorry, 80m to the 3 plus 8m equals 240p plus 80m to the 4 plus 40m squared. So I've just taken the two negatives and taken them to the other side of the equation. Okay, so now if we take that, okay, and we look at equation 2, so we're going to sub that, so sub into 2. So if we have a look at, so if we look at 2, so again, collecting the things that are the same. So if I look at the bits that have the yellow underline, so that bit, and that bit, right? What's left, if I substitute, okay, pardon me. Okay, so what we're going to have is, what's left is that the bits with the yellow underline are going to be replaced by what they're equal to down here. So it's going to be 240p plus 80m to the 4 plus 40m squared. Right, there's those things there, which is this bit here, plus 80m to the 4 plus 40m squared. Okay, so if we simplify that a little bit, that's going to be equal to 240p, right, plus 160m to the 4 plus 80m squared. Okay, now if I take that out, 240p plus, let's take out a common factor of 80m squared. So we're going to have 2m squared plus 1. Okay. Okay, and from here, the last step is to take out a common factor of 240. So we're left with p plus, well, if I take 240 out, that's going to leave me with 1/3. Okay, m squared 2m squared plus 1. Right, so what we have there is that, therefore, it's a multiple of 240. And I'm going to come back and prove why in a second, but let's just finish it off. Therefore, p, sorry, whoops, not that. Therefore, by mathematical induction, n to the power of 5 minus n is divisible by 240 for odd values of n. Now, I can hear some of you in the background, hang on a minute, there's a fraction there. How can that possibly be the case? Well, if we think about this for a second, if we think about this bit here, oops, I just missed the, hold on, there we go there, this bit here, all right, then remember that m is greater than or equal to 1. So when m is 1, so let's let m equal 1, then what's 2m squared plus 1 going to equal? Okay, well 2m squared will be 2 times 1 plus, which is 3. And what's 3 times a third? That's 1. So that's a whole number still. When m equals 2.